Alrighty, welcome back everybody. It's your main math man, Mr. Shane, coming to you live from Summit Academy. In this video, working on that Unit 7, Lesson 2, still talking about these polynomial functions and what they look like, whether it's on a graph or maybe in this lesson, we're going to be talking about the equations. So, for our warm-up, it looks like this. It says, describe how to identify the roots of a polynomial in a graph. So this is kind of summarizing what we talked about last lesson, in lesson number 1, but we can say something like this. Let's say, how do we identify the roots on the graph? We look, let's say the way we identify the roots, which one we say that, we're talking about x-intercepts, solutions, or zeros. Again, any of these 4 words are interchangeable, but we could say when the way we identify the roots, meaning x-intercepts, solutions, or zeros of a polynomial on, on a graph is by looking for where the curve hits the x-axis or where y equals 0. When I say y equals 0, it can also mean f of x. Let's say slash f of x equals 0. This is what we're saying when we're talking about those x-intercepts, roots, solutions, or zeros. It's still that same definition that we talked about, back in semester 1, where we had those quadratic functions. It's still the same idea. So it's wherever that curve hits the x-axis, and mainly where our function is equal to 0. So our y values at whatever point is equal to 0. All right. So just make sure you signed in, make sure you click and share with class, so that way it saves your work. All right, but we're talking about this, we're saying that students will, in writing or verbally, identify the x-intercepts of a factored polynomial using that language of math. And so we can use those different examples that are in there as well. But it looks like this. So just to kind of recall some ideas that we had before, it says recall back to quadratics when we were given this equation. So let's say if we had f of x equals parentheses x minus 2 times parentheses x plus 3. We know that the x-intercepts of 4 zeros are located at 2, 0 and negative 3, 0 because we simply set the equation equal to 0 and separate the equation using the zero product property. So if you look at the image on the left, again, we're kind of saying a couple ideas here. A times B times C, so we're just saying, like, in general, you could have 3 different things multiplied together, and we're setting it equal to 0, or you could have more than 3 things multiplied together. Any of those pieces of the equation can be set equal to 0, meaning this. So if we're saying, those 2 factors, x times x plus 2, we set both of those equal to 0, and we can get our answers. So it's almost like we have x plus 2 equals 0, which means we take the opposite of that value to get our answer. So make sure you're thinking, again, in your equation, whatever you have in your equation should be opposite from what you have on your points. So meaning in that example that we give here, it says x minus 2. That means that one of our zeros is going to be at positive 2. And then the other one, since it says in the equation x plus 3, we have to take the opposite, and we're going to say negative 3. So it's still the same ideas as before. Again, really simple. Be able to just make sure you're checking the equation versus what you have on the graph. Okay, so same kind of idea, but when we're talking about polynomials, we're mainly talking about things that have more than 3 as its degree. So usually we start at degree 3 and then we move on from that. When we call a quadratic, is still a polynomial because we are saying, hey, this is still a second degree polynomial, and its exponent, its highest power, is going to be 2. So it says the zero product property works on all polynomials in factored form. So on this example here on the left, there's a couple examples here. So it has, x minus 4 in parentheses times x plus 7. You can take the opposite of those two numbers, get your two x-intercepts. We have, there's going to be, one of them is going to be negative 7, the other one's going to be positive 4. Look at your second idea, same kind of equation here, two x-intercepts. Again, when x is by itself, it's just going to be 0, and we take the opposite of whatever number is inside those parentheses. Then same thing with even if we have 3 of them. Notice how x is by itself. Again, even though I have a number times it, it's still going to be just 0. So unless I have that plus or minus something, I just have to let it be 0. But again, also to make sure you're just thinking, anytime I have an equation, I can always graph it out and see. So let's say if I wasn't sure about that one, I'd say 3x times x minus 1 times x plus 4. Notice how I can get a graph and I can click on those x-intercepts. So I should be able to find those x-intercepts, again, by clicking on those points. Notice how all those y values are 0. But again, I don't see anything with a 3 in here, but it's saying that this x-intercept of 3x goes through 0, 0. So make sure you're checking those out for yourself. Again, too, if you, let's say you could set it equal to 0, so we said we separate each of these pieces. So I have two parts here of x, and then I have another set of parentheses, 2x minus 5. So normally people would just take the opposite of negative 5, but we actually have to set this equal to 0. So it says 2x minus 5 is set equal to 0. So I'd add 5 to both sides, and then I would divide both sides by 2. So my x-intercept should be at 2.5. So let's actually check. I'm going to graph that out and check. So it's going to be, one of them is going to be at 0, the other one's going to be at 2.5. So let's check it out. So I have x times 2x minus 5. Again, it's a quadratic function because I have two x's in here. So I have one point goes through 0, 0, other point goes through 2.5. Alright, so make sure you're checking it out on your graph. Again, even though it only has two x-intercepts, it's still just a quadratic function, but it's still technically a polynomial. Alright, so try practicing some more on here. Alright, so be able to identify these zeros. So really simply, again, take either two ways of doing this. I would suggest practicing to make sure you can see, again, I can look at this equation and take the opposite of it, or I can also just graph it out. So anytime I have the equation, I can always, just highlight it. So I'm going to say highlight, Control C to copy and paste, and then I get my graph. Again, if I need to zoom out at any point in time, I certainly can, but also too, I like kind of just stick it to the origin. But if I notice, I have 3 points where the curve hits the x-axis. So this kind of reassures me that, hey, I'm on the right track. All right, so let's check it out. So if I want to do it the old-fashioned way where I just kind of look at the equation, take the opposites, I would say, okay, I have positive 2 as one of the x-intercepts. I have positive 5 because the opposite of negative 5 is positive 5, and then the opposite of positive 9 is negative 9. And that says to write each x-coordinate from least to greatest. So that means from furthest left to furthest right. And when I'm saying for left and right, I'm talking about the graph. So notice how I have negative 9 starts this off. So I'm going to say negative 9 is going to be one of them. I'm going to say positive 2, and I'm going to say positive 5. Let's check it out on our graph as well. Always, anytime you have the equation, always graph it out. So I have negative 9, positive 2, and positive 5. Again, really simple. Make sure you try these out for yourself. Moving on to the next one. Same kind of idea. I have 3 pieces, which means I have 3 boxes. So I can count. I can kind of see it. I have one x, another x, and then a third x. So that's why I have 3 boxes in here to kind of show that I have 3 x-intercepts. All right. So let's be able to think. Again, I can graph it out, which I always will. I'm going to highlight it here and I'm going to copy and paste. I'll go to the graph here in a second. But let's kind of look at our equation here. So I have x all by itself, even if it had something attached to it. Even if I had an x squared here, if this was x, let me kind of demonstrate what I'm showing. If I said I had x squared here, I would still have the same point that it goes through. It still goes through that point of 0, 0. So one of these is going to be 0, which is good. I have a -6 in my equation, which means I have a +6 as my x-intercept, and I have a +1 in my equation, which means I have a -1 on my graph as my x-intercept. So be able to kind of see and plan out how I'm doing these. You can notice on your graph, I can click on those points. And a lot of people are going to click those extra points when they see these curves. And notice how my y value is not 0. So even though it's a clickable point, I don't need it. I'm looking for where the y values are equal to 0. Notice how it goes from left to right. It is from least to greatest. So I have -1, 0, 0, 0, and 6, 0 are the points on the graph compared to the equation. Okay, moving on. Same kind of idea. Let's do it like this. So it says identify the zeros. It says f of x equals x times x plus 2 times 2x minus 4. Okay, so what I wanted to do is I'm going to pull this up separately so I can draw on it. But what I want to show is mainly this set or this pair of parentheses right here. I'm going to actually take this apart and kind of draw it out. So I have 2x minus 4. I'm setting this equal to 0. I can also set these other ones equal to 0. But I just kind of want to demonstrate what this looks like. So on the side here, I'm going to set this equal to 0. So let me say, let me actually put it up here. I'm going to say set each equal to 0. So for example, I'm going to say, all right, I have 2x minus 4 is equal to 0. And I take it like a, normal equation I can solve. So let's say add 4 to both sides. Add 4 to both sides, so I have 2x equals 4. And I divide both sides by 2. So I divide both sides by 2. And I can say x equals 2. So that's going to be one of my x-intercepts. Same idea, I can set whatever I need equal to 0. So I'm going to set, let's take this box away. I don't know, I'm going to say, if I set this equal to 0, it's going to be really easy because I just have my x-intercept already. So notice how it works out. I'm going to say I have x equals 0 is going to be one of my x-intercepts. And then same idea for this one. I set x plus 2 in parentheses. I'm going to set that equal to 0. So I have x plus 2 equals 0. I do my one step, which is take the opposite of that number inside the parentheses. So I subtract 2 from both sides. I'm going to say stop. Okay, sorry about that. All right, so we subtract 2 from both sides to get our x-intercept. So we're going to say x equals -2 as our last x-intercept. So notice how, again, I can set, this is kind of like the old-fashioned way of doing it, being able to kind of set it equal to 0 without even graphing it, but I can set each of those equal to 0. I can also check on the graph, so that's actually what I'm going to do. I'm going to, let me minimize this, or actually take this away, this one. Okay, so now let's go back to our Desmos page here. Same thing, I'm just going to graph out to make sure that I'm on the right track. And anytime you have the equation or anytime it gives you equations as possible answers, please make sure that you're graphing each and every one out so that way you can double check your work. And you'll be able to get some information a lot faster from the graph than compared to one you're just trying to do it by hand. So there's my 3 x-intercepts. Exactly like I said. -2, +2, and 0. Let me put them in order. I'm going to say -2, and then I'm going to say 0, and then I'm going to say +2 as my 3 answers. Again, notice how on my curve I have 3 places. I should say 3 places where it hits the x-axis. Again, that's how I'm trying to do. I'm trying to identify where my x-intercepts are. It's where the curve hits the x-axis. It is where my y values or my function is equal to 0. All right, So now let's try coming up with that factor form. So what it means by that factor form is when it's, several sets of parentheses. So this is very important because what our end goal is going to be is we're going to try to, on the test, we're going to try and make an equation similar to how you guys made an equation in vertex form back in semester 1. It's going to be a similar idea, or intercept form, but we're going to try to make an equation of a polynomial function that goes through certain x-intercepts and goes through an additional point. And we'll kind of see that in following lessons, but that's what our main goal is. And this is a helpful equation because we need this to be able to come up with what our general form is. So in general, we're going to say f of x equals a times each of those sets of parentheses, where b, c, and d are going to be those x-intercepts. And for the most part too, I think in class I normally have a minus sign here to kind of show that we need to take opposites. But as long as you're signing, it's a this is an x-intercept. Also, to make sure you're careful on that double root. If it was a double root, I would have an exponent 2 on whatever spot it is. But for the most part, these are just single roots. Also, too, it tells us that leading coefficient just as important as it was in semester 1 class. Again, that's kind of tells us whether it's positive or negative, which way the orientation, meaning which way it is facing, and whether it's vertical stretch or shrink on that polynomial. So same kind of ideas with the quadratic function as a polynomial function, be able to have an intercept form now because we're just having several sets of parentheses. So for this one, if I took out the dot dot dots, I would say that this has 3 x-intercepts or 3 roots just because it has the 3 sets of parentheses with x in it. All right, so let's try this out. So it gives you what a is, and it gives you 3 x-intercepts. So so what we're supposed to do on this one, it says write an equation for a polynomial that has regular roots, meaning single roots, at 3, 0, -2, 0, and -4, 0. And there's a vertical stretch of 2, meaning a equals 2. So in general, let me actually write this up here, so give me 1 second. Okay, so I just want to take a little snip so that way I can write on here. But what I want you guys to do is, really focus on that general form. So what I just, on that last slide is what we had here with f of x equals a times x minus b times x minus c times x minus d. I'm going to keep like this. Actually, I'm going to have 3 dots here to kind of show that, hey, it keeps going. If I needed 4, I'd have x minus e or something like that. Actually, let me write e. Let's go to g just to show that, because we already have f here and we already have e is already a scientific number. So for this though, I have 3 x-intercepts because it tells me in the equation, or excuse me, it tells me in the problem already, so I already know what these should be. Again, I should make sure these need to be opposite. These need to be opposite from what you have in the points. So if we know the points on the graph, I know that I have to take the opposite of them to write them in the equation. So it's going to look something like this. I'm going to still say f of x. I still say f of x equals. I'll kind of show you guys, how to type this in a second, but it tells me what a is. It says my vertical stretch. Notice how it doesn't say shrink here because it's greater than 2, or excuse me, greater than 1. Is a number greater than 1, which tells me it's stretch. So I'm going to say, all right, a equals 2, put it right in the front, all by itself. Don't have an x there because it doesn't say it goes through 0, 0. Next part. Again, the order of these does not matter. As long as you include each of these sets of parentheses, you should be fine. So I should have 3 sets of parentheses with x in them. Again, the order of them does not matter because of that commutative property, or commutative multiplication property. So for example, if I was to change the order of the sets of parentheses, that would be fine. But as long as I have, what I need, I'll be good. All right, so on the graph, it tells us it is positive 3. That means my equation, I need to take the opposite. So I'm going to say x minus 3 is going to be one of those x-intercepts. Go to your second go to your next one. I'm going to say it's minus 2, which tells me I need to be opposite. So I'm going to say I now have x plus 2 in my set of parentheses. And then for my last one, I have x minus 4, or excuse me, x is equal to negative 4, which tells me in my equation I need to have plus 4. So there's my 3 sets of parentheses, and I can always graph to check. So what I'm going to do is I'm going to switch back. I'm going to switch back to my Desmos here. Now let's try typing out. Let's say I have f of x equals, I have 2 parentheses x minus 3, parentheses x plus 2, and x plus 4. Okay, and before I kind of submit that, I want to make sure. Let's graph it out. So let's have that graphed out. Again, I have 2 at the front, so my I have my function is slightly more skinny compared to your normal parent function, but we can say that. So let's make sure it goes through those 3 key points here. So it goes through negative 4, 0, goes through negative 2, 0, and it goes through 3, 0. And so I know I'm good, so I can hit submit on it. So make sure you graph it out and make sure it goes through those key points. If I wanted to, and instead of clicking on them, I can graph them out to make sure, but I can also just click label so that way I can see where they're at. So as long as that curve goes through those 3 points, I should be good. All right, and lastly, for that exit ticket, it says write a second set of directions you could give a student taking Math 2 to help them identify those roots of a polynomial using an equation. Remember, they have no clue what this is, so try to write this as best as possible. I'm not sure why it kind of says that, but try it out. Again, kind of use some directions. Think back, go back to your last couple slides here. Think about how it's similar to those quadratic functions. But be sure to ask questions, and as always, super slam that subscribe button.